Hi YouTube, how are you? Hi everyone, how are you? I hope you all guys are doing great. In this video, we are going to see the second pillar of OOPS, which is inheritance. Till now, we have created lots of video about intro, class and object, access specifier, constructors, where we have seen the difference between init and new, methods, class, instance, and static methods. In encapsulation, we have seen getter setters, property methods. So if you haven't watched it, please you can watch. And if you know all this thing already, let's move directly into inheritance, which is really very important and very useful topic. So what actually inheritance is? Inheritance in Python is a way to create a new class which we call as child or derived from an existing class which is called as parent or base, so that the child can reuse or extend the parent's functionality. What I want to say is, let's suppose we have a base class. Okay, we have a base class. We generally call it as base or maybe parent. Okay, we also call it as parent class. It has some method. Okay, let's suppose there is a method called a. Okay, and there are some implementation of it. Now let's suppose we are trying to create a class which is again going to use a only, and let's suppose there are 100 lines of code in a. Then what we can do is, from this base class we can create a derived class. Derived class, or we also call it as child class. Now this child class, as it is inheriting from the parent, then whatever the parent has qualities, the child will also have that qualities. So this definition or this method a can also be now accessed from this derived class. Also, this has one more name. We call it as superclass, and this is called as subclass. So the verbiage is different, but the soul is same. So either you call it as super, base, or parent, or either you can say derived, subclass, or child. What are the benefit of it? Why inheritance came into picture? It promotes code reusability. Now, one way was, you can define this a here also, and then the same a can be defined here also. But if let's suppose it is of 100 lines of code, here also 100 lines of code, so it is not good because we are just repeating ourselves. So code reusability, because now as child is inheriting the code from its parent, then it don't have to repeat it. So we are having a code reusability. Helps in extensibility. Child can also add new features. So parent, let's suppose, have a method. Child can also add its own method. So it will have the method of a, which is parent, as well as its own method. Provides a logical structure for modeling real world relationship. When to use it? When classes share a common behavior, we generally use inheritance. So let's see what a very basic example. Let's suppose we have an animal, and animal can speak maybe. Okay, all the animals can speak. So we can say animal speaks. Okay. Now, if I have an animal or like dog, so dog is an animal. So whatever quality animal has, every quality dog should also have. So let's create a class dog, and it should inherit from animal. So animal, okay, or we can say it is extending animal. Okay, let's suppose just we are adding pass, nothing. Okay, now if I create a object of dog, okay, dog1 is equals to dog. And now if I try to access dog1 dot speak, can you just see that speak method is not defined inside dog, it is defined inside animal. But dog is inheriting animal, so whatever qualities, whatever methods, whatever variables animal have, all this method and everything will be also present in the inherited class, which is dog. So if I have to run it, python 3 6, sorry, python 3 tab 6. So now you can see it. Let me just clear it. See, animal speaks. So this is basically we call as parent class, or maybe we call as base class, super class. In some way we also call it as super class. This is basically child, or we call it as derived class, or we call it as subclass. Okay, this is very basic syntax of inheritance. Now let's see some types of inheritance. Okay, so let's see some types of inheritance. Let me again go to the blackboard. So we are going to see types of inheritance. First type is single inheritance. Single inheritance means one parent, one child. Okay, single, sorry, single inheritance. So one parent, one child. So we have a parent class and a child class. One parent, one child. Okay, so let's code it with an example so that you will understand it much better. Let me just comment it out. So first we are going to see single inheritance. Okay, so we can have a class called vehicle. Now this vehicle class can have a method called start which takes self, and it can say like print vehicle started. Okay, now car is basically a vehicle. Okay, class car, and it can extend vehicle because if you are having a car, it should have a method to start. Okay, so we can say, and now every car or every vehicle will have a way to start. So that's why all the attributes of vehicle will be now accessible in car also. Okay, so we don't have to add those definitions, because definitely if it is a car it should start, otherwise why we are buying it. Okay, then let's suppose we are also trying to provide some methods, or you can say functionality to only car, not vehicle. Okay, so this car can also have brake. Okay, definitely every vehicle will also have brake. So we can say it has nitro boost. Okay, so self, and we can say uh, nitro boost activated, because every vehicle will not have nitro boost, but this car is a type of vehicle which has this kind of feature. So car 1 is equals to, we have created car, and we don't have to pass anything actually. Then car 1 can access start because it is inheriting it from the parent class, although start is not defined in this car, but it is inheriting or extending the vehicle class. So whatever methods which are in vehicle will also present in car, so it can also access start, and it can also access its own method which is nitro boost. So if I just run it, it should able to access both vehicle started and nitro boost activated. But if I just create an object of vehicle, it will only have start method, it will not have nitro boost method. Okay, because this is the base class. Okay, and this is the in you can say derived class. So derived class will have all the functionality of the base class as well its own functionality. But this is an example of single inheritance because we have single parent and a single child. Okay, now let's move to multi-level inheritance. By the name it is very clear that you might have guessed multi-level inheritance. Multi-level inheritance. So multi-level inheritance means you can say like grandparent, parent, and child. So we have a parent, then we have a child, but parent is also having its own grandparent. Okay, parent is also having grandparent. Okay, so basically there is no term as grandparent, but you can think like there is a chain that these are parents and child, these are parent and child, and so on. Okay, so again let's see an example of multi-level inheritance. Okay, and please code along with me if you want it to be practiced, so that it can be helpful for you. Multi-level inheritance. Let's suppose we have a device, and every device should have a functionality to power on, because without power on, how the device will work. So it can be like device power on, maybe just device power on, sorry, device power on. Okay, so we have this. Now computer is a kind of device. Okay, so what we can say that class computer will be inheriting from device, sorry, device. Okay, so all the functionality of device will be also available with the computer object. Now computer can boot, so it can boot, print, we can say booting up. Okay, now laptop is a type of computer. So laptop is a type of computer, so whatever computer has functionality, definitely laptop should have. So this is also a class. Okay, now dev portable, because laptop is a type of computer which is portable. So we can say uh, I am, just don't mind this print statement. I'm writing anything. Okay, so now device has a power on functionality. Every computer should have power on as well as boot. Now laptop should be having power on functionality as well as boot functionality, and itself its own property which is portable. So if we create an object of laptop, so laptop should have all the functionality, each functionality. So I can access anything from laptop dot power on, sorry, maybe first just to power on. Laptop will also be accessible its parent, which is computer was having boot, it can also access that. Laptop can also access portable. So if I just run this program, definitely it should be able to run each and everything. See, device turn on, boot, booting up, I am portable. So this is multi-level inheritance. So laptop is inherited from computer, so all the functionality of computer should be also available in laptop, and laptop itself has its own functionality. Now computer is inheriting from device, so whatever device has functionality, it should be available in computer also. So this is kind of a multi-level inheritance. Okay, if I create an object of computer, okay, so computer is equals to computer. So now can you tell me which functionality should computer have? Just pause this video and let me know in the comment section. So computer can have its parent functionality. Who is the parent of computer? Device. So device has which kind of functionality? Power on. So it definitely should have power on. Now computer can also have its own functionality. What is its functionality? Boot. So it can also have boot. But can computer access this portable? No, because portable is not a functionality of computer. It is its uh, portable is a functionality of its child class. Okay, so child have all the functionality of parent, but parent cannot have the functionality of child. Okay, so if I just run it, it will work. But the thing is, I want to teach you that parent cannot have all functionality of child. Child can have all functionality of parent. So this is multi-level inheritance. The third inheritance that we are going to see is hierarchical. Spelling, I can, maybe I can write it wrong. Hierarchical, okay, and to look for this spelling. Hierarchical inheritance. It means that one parent but multiple children. So you have one parent and there are multiple such childrens. Okay. So this kind of inheritance is called as hierarchical inheritance. Again, let's see the code so to make it much more clear to you, because when you code, you understand it much better. It should be H Hierarchical, I guess. Inheritance. So hierarchical inheritance. So we have a single class and then we have multiple child class. So let's suppose we have payment, and if you make any payment class, it should have a method to pay. Otherwise, which kind of payment method it is? So print, we have a uh, paying paying kind of thing. Now if I create a credit card payment, okay, so credit card payment, so credit card payment also should have pay method, so we don't have to define pay method, we can just inherit it, payment. Okay, and don't think that why we are inheriting it, it is very simple, we can again define it, but in general pay can also have 100 lines of code. So it's not a good practice to repeat code again and again, it violates the dry principle, means it dry principle means do not repeat yourself in code, we should not repeat ourselves. Okay, so it can add its own functionality and also it can override it. Okay, so there is a new concept that I am teaching you, that whenever you inherit something, so you can add your own functionality. So now your base class will have the functionality of parent as well its own functionality, but let's suppose you are trying to modify your parent's functionality only, then you can override it. So now self, now if I just write print and I can say credit card payment, and similarly if I have another class, let's suppose UPI, UPI payment, and it is also, it should also have payment, and again def pay self, and I'm saying print, and I'm saying like UPI payment mode. Now if I create an object of credit card, credit card object is equals to credit card, sorry, sorry, it should be credit card payment, and if I just in credit card sorry, it's credit card object, in credit card object dot pay, if I do this, do like this, what should be the output? Just think for a moment. We have a payment which is having a pay method. Now we have inherited payment into credit card payment because every payment method will have a pay method. But now instead using the method of our parent, we are modifying it, we are overriding it, and we are making our own functionality. So only this should work, credit card payment. It should not work like this because we have already overridden the functionality, we have changed the functionality, we have modified the functionality. So it is credit card payment. If I create an object of, let's suppose, UPI object, and I say UPI payment, and maybe instead of calling credit card object dot pay, I'm calling UPI object dot pay. Now what should be the output? Should it print paying or it should pay UPI payment mode? Let's see. So it should pay, it should print UPI payment mode because we have overridden it. Okay, is it fine? Now let's move to, and this is in hierarchical inheritance because there is one parent and there are multiple childs inheriting from the same parent. Is it clear? The third or the fourth one is multiple inheritance, where child inherit from multiple parents. There can be also functional. There can be also chances where this will just the reverse of hierarchical. So fourth is multiple. So multiple means there will be multiple childs, or sorry, not multiple childs, it will be, sorry, why it is not working, just take a big eraser. So we can have multiple parent but one child, but we can have one child class. So this type of inheritance is called as multiple inheritance. Some code of or example of multiple inheritance, because if you code you understand it much better. So we have multiple inheritance. sorry, inheritance. So let's suppose think of a scenario where you have digital wallet. A digital wallet can have multiple features like wallet, reward. So the base class can be different. Like let's suppose we have wallet. Okay. So wallet class we have maybe just in wallet we can add money and maybe just add self or and say print wallet feature. Then we can also have reward. So reward. So r- in reward def we can say redeem points as it is generally we in reward we reward redeem some points. So print we can say reward. Okay. Now any digital wallet that we will create will definitely should contain this methods or this functionality, which is we should also have wallet, we should also have rewards. Now sorry, yeah, so it can have its own method also, it can have its own functionality. Let's suppose pay is its own functionality, so it can have just say pay, sorry, happy not pay. Now if I create an object of digital wallet, so it can be digital wallet and digital wallet as dw.pay. So it can also access pay. It should also have the wallet functionality, which is add money. It should also have the reward functionality, which is redeem points. So it should have all the functionality. Why? Because the child class have all the functionality of parent. So who are the parents of digital wallet? Wallet and reward. So the functionality of reward should be there and also the functionality of wallet should be also there. Simple. So pay, wallet and reward. So this is basically an example of multiple inheritance. There is also important concept called method overriding. When a subclass provides its own implementation of a method already defined in a parent class, we call it as method overriding. We have already seen it. If you see it here, just focus here. In hierarchical inheritance, we have already seen it. So payment, which was parent, was having its own method, but the child wants to modify the method which was already defined in the parent class. So this in this scenario we call it as method overriding. Okay, so it's simple. So I don't want to over explain again this method overriding. Okay, so we have also seen method overriding. Then there is a concept called MRO. Okay, I want to show you. This is really important. Even for some time, I was also not knowing what is MRO. Okay, so method resolution order. MRO basically defines. Let me write the full form. Method resolution. I guess it's resolution order only. Maybe I would be wrong in full form. So method resolution order defines the order in which Python looks for a method in a hierarchy of class. It is important in multiple inheritance to avoid ambiguity. You can see the order with doing .mro. Let me just show you how you can see it. Okay. Let's create a multiple inheritance like we have class A which is having a function called show maybe. Okay, and we are just adding some random stuff like pass. Okay, now we have class B which is being inherited from A, and it can also have some method like show maybe. Okay, so show self pass. Now we are doing multiple inheritance, so class, or we can do any kind of inheritance. Let's suppose we have one parent and multiple child, so it is kind of hierarchical inheritance. So C is also inheriting from A. Okay, and now def show self. Okay, pass. Now if I want to see the MRO of it, what I can do is I can create an object of C. Okay, and I can do like C dot MRO. MRO. Okay, let me just print it. Okay, So now let's run this program once, this Python file once. C object it has no attribute MRO. So what we can do is we have to do this. Do like this, I guess. D dot show. C object has no attribute MRO. Am I missing something? Okay, MRO is regarding the class, I guess. Okay, yeah, it is regarding the class, not the object. So we should do like this. See, now we have the MRO of it. Okay, so see how the MRO looks like. First, main.c means C class. Then it will resolve for A because it is inheriting from A. Okay, then we have a object thing. Basically, object is like whenever you have a base class, actually Python resolved its Python C from this point of view. Always. Okay. We don't have to write it because by default it takes care of it. So that's why we have object. If we want to see a logical order, then what we can do is B is inheriting from A, and let's suppose C is inheriting from C. So A is having a base children as B, B is having a children as C. This is what this is looking like, a multi-level inheritance. Now let's see how it will look like. So if I run this C first, C will be given the preference, then B will be given the preference, then A will be given the preference, and then object will be given the preference. That's why if we create an object of C and we write something inside C, even the function name is same on A and B, C will be given the power to execute, because in MRO this is at the top, then we have B, then we have A. So it gives how we can resolve the order kind of. Okay, so this was about MRO. Now you will come across a function called super method. So what actually super method does is, super method lets you call methods from parent class without naming them explicitly. It works with MRO, so it is consistent in multiple inheritance. Like let's suppose we have a class A, okay, and class A has some function called greet. Now, maybe we can just add some random stuffs like hello from hello from A. Okay, so this is the base class. Now let's suppose we are inheriting A from B, and again we can do like this: greet self, and we can say print hello from B. Hello from sorry, hello from B. Now at this point, I want to also call the method of A. Okay, now if I create an object of B, okay, and maybe I say greet. So what do you think? What will be the output if I just run this? Sorry, if I just run this, so I will say hello from B. But let's suppose I want to also call the method greet from parent. So what I can do is super dot greet. So unknowingly, it will refer to the parent class. So see, hello from B, hello from A. Okay. So super lets you call the methods from parent class without naming them explicitly. Okay. Also, if I want to show you the MRO, this is important actually. MRO. So B.MRO. Let me just clear it. Okay. So first there is B, then there is A, and then there is object. So there are two definitions of super. Super lets you call from the parent class as well as the next class which is in MRO. So B, when you write super for B, it is referring to the next class in the MRO which is A. But generally we call it as it inherits from parent class. So this is the very basic difference which you should understand. So if someone asks you like uh, in MRO, which method is called when you write super? So you should not say previous method, because we think that okay, it is a parent, so it should be in MRO it should be previous than A. previous than B, but actually it's the next. Okay, so in super, if you super basically lets you call to the methods from the parent class as well as to the next class in MRO. Okay, both are same kind of. Generally, we use as in terms of parent. Okay, now so we have a diamond problem, which is a common problem, and a lot of time it is even asked in an interview. So, what actually diamond problem is? When a class inherits from two classes that both inherit from the same parent, who should be get called? Okay, what I want to explain is, let me write some code. Like we have a class A. Okay, inside class A we have a method as show. Okay, and in show we can print like this A. Okay, now we have two more class B and C. So class B, which is getting inherited from A, and it has again a method as def show, and we are passing self, and it will print just B. Now we have another class C, which is also getting inherited from A only. Okay, but this is C. Now we have a class D, and it is getting inherited from both A and B. Okay, now if I create an object of D, if I create an object of D, and if I do like show, the problem is which show should be called, because there is a, why it is called diamond, because we have A and B and C both are getting inherited from A, and D is getting from inherited from ABC. So if you connect all the dots, so it is kind of a diamond problem. So now when we just had one class like A, B, and D, let's suppose we have A, B, and D. So D will call the show of its parent. But now D is having two parent, B and C, and both are having show method. So which show should be called? Now let me just run it. Cannot A and B, print show, show, show. So we have C and D. Okay, sorry. It should be B and C, na? Okay, because A, then we have two children BC, and then we have a child which is D. Now it is getting called B, means it is printing the show of B. Now why this happens? Why not C? Okay, there was equal chance for B and C. The answer rely on the way Python solves it. Python solves it using C3 linearization. If you want to learn more about C3 linearization, I can also create a video or you can search it. Basically, MRO is C3 linearization, I think. So how it came, how we got B, the answer lies in MRO. Okay, so thanks to MRO, it made the life very, very simpler. So if I just clear the screen and let me print it again, see, first of all in MRO there was D, then there was B. So when we created an object of D and call show, so it will look for the nearest class, which was B. So that's why B was printed, and then C, then A, then A. If in MRO second class might be, let's suppose at some instance of time, second class is B, or sorry C, then we can say D, then C, and then B should work. If I write it like this, let's see what will happen. Okay, now I am getting D, C, then B. So which is closest to, it depends upon the way we are writing. Okay, I'm not sure whether it depends upon the way we are writing in the order like D, C, B, and then A will be the MRO or not. You can find it on internet, just you can do a simple Google search. But from this is simple experiment, we can say that see that MRO is basically responsible for solving this C3 linearization, which is a diamond problem that can be solved using MRO. Okay, so that's it, I guess. And I think this object I have already explained that it the base class actually. inherits object. So if you see this definition, this is the base class of the class hierarchy. When called, it accepts no argument and returns a new featureless instance that has no instance attribute and cannot be given any. So that's why at the beginning we also have object. So generally we keep it as empty. Okay, we don't add anything. Okay, so that's it about inheritance. We have seen a lot of things. We have seen what is parent based superclass, then we have seen child derived subclass, then we have also seen types of inheritance, where we have seen multiple type of inheritance, multi-level, multiple, single, and also hierarchical. Then we have also seen MRO, which is really important, interesting one. And we have also seen diamond problem. If you want, I can also create another separate video on MRO if you want more depth on MRO. Okay, but this much is enough. So meet you in the next video with some other concepts. Maybe next we can take polymorphism and let's see. So if you like this video, please subscribe to my channel, like this video, and if you have any doubt, let me know in the comment section. I will be very happy to help you all. Thank you. Have a great day.